Back Math 9. Today we are going to learn about algebraic method of multiplication of monomial by polynomial. The type, if you guys remember, it's ax bx plus minus c type. Or today we may do more, but technically this is our main goal today. As you may notice, when it comes to algebra tile, it takes quite a bit of a long time. However, once you create all of those tiles in a table using polynomial on the either horizontal or vertical column, or if you use monomial, either vertical column or horizontal row at the very top, it doesn't matter which one you choose. Good thing about algebra tile method is it's very visual. And at the same time, you can actually find zero pairs easy like that. However, like I mentioned, it does take a while. So when you multiply polynomial expression by monomial, you actually need to treat monomial term as if it's a constant. So what I mean by that is, do you guys remember 5 bracket open 3x minus 2 bracket close, something like that? Imagine it considered as 5, except it does have at least a single degree, which is x, y, z, a, b. You got the idea. We are going to use same skill, which is distributive property rule. So let's go through this. I will consider negative 2x as if it's a whole constant. So that means you will distribute to each of the member of, or each of the term I like to say, inside of the polynomial. In this case, it's binomial, so as you may notice, I have 2 arrows. Once that happens, here's what I do. I know it's tedious, but I want you to follow these steps one by one. Negative 2x multiplied by negative x plus negative 2x multiplied by 4. And again, as you may notice, I put plus because that's a sign that separates these two terms inside of a binomial. Once that happens, negative 2 times negative 1, whole number or integer first, that gives you positive 2. X times x, that's x squared. Plus, negative 2 times 4, that's negative 8. X and nothing, that's just x, because that means it's like 4 and then there's 1. Even though it's not 1x per se, but there's just single variable over here. Whenever, as you may notice, I keep the negative sign inside of the bracket and positive, and once that different sign situation happen, I just change that adding sign into subtraction sign. 2x squared minus 8x. There you go. As you may notice, very simple, very precise, and you don't have to deal with construction of the tile arrangement. Instead of 2 minutes for each question, this takes about 30 seconds to 45. So it's quite efficient method. But you gotta be careful, however, that basically, ladies and gentlemen, how can I say this? Sign will be your enemy. What I mean by that is negative multiplied by positive. You have to understand that multiplication of integer rule that you learn in grade 8 is still play a huge role. In fact, it play a more important role. Let's do the other part. Monomial, which is my negative 5h over here. Gotta multiply with negative 3h. Gotta multiply with positive 13. So once that happens, negative 5h multiplied by negative 3h plus negative 5h multiplied by 13. Negative 5 times negative 3 give you positive 15. Don't have to put positive. You can just put no sign in front. H and h give you h squared plus minus 5 times 13. You can use mental math. You can use your calculator at this point. It's your choice. It gives you negative 65 and h. Simplify the sign, which is 15h squared minus 65h. Just like that. Let's do more. Today we're going to do some complex examples too. So just for the heads up. Alrighty. So, positive 4a with binomial 3a plus 2. That means I got to multiply and group them together. 4a times by 3a plus 4a times by 2. 4 times 3, that's 12. 8 times 8, that's a squared. Plus 4 times 2, that's just positive a. So I didn't put bracket and a. Other parts. D is monomial. D times d squared minus d times 2d. Note the fact that because I put negative over here, that becomes positive. Or just treat sign and number differently. That also helps. D times d squared is basically d to the power of 3 minus 2 times 1 is 2. D times d is d squared. There you go. I hope you guys start to get the pattern. It's quite straightforward. Same thing. 2v times negative 3v plus 2v times 5. Negative 3 times 2, that gives you negative 6v squared plus 5 times 2 is 10. And then v. Something like that. Now things can get a little bit tricky now because sign negative is included for monomial. So bracket open, negative n times negative 2n minus negative n times 1. As you may notice, the last term, be careful. I kept the negative as subtraction and the number I separated. Negative 2 times negative 1 is positive 2, so no sign in front. N times n, that's n squared. Minus 1 times negative 1 is negative 1, and n times nothing is just n, so negative n times 1 is just negative n. Note the fact that it's double negative for the second monomial over here. Second term, sorry. So 2n squared plus n becomes my final answer for question D. As you may notice, I included negative 3m, including the sign for both situations. Negative 3 times 2, that's negative 6. M times m is m squared. Minus negative 3 times 12 is negative 36. And simplify the signs if it's necessary. In this case, yes, I gotta simplify double negative into addition sign. Same thing happened, except it's a little easy. 2g times negative 2g plus 2g times 3. Fortunately, the monomial is positive, so that's why it's a little bit easier. Less room for screwing up the question too, to be fair. 2 times negative 2, that's negative 4. G times g, fancy way of saying that, is g squared. Plus 3 times 2 is 6. Then single g. So negative 4g squared plus 6g. Those are the questions that I have in the workbook. Now, you will see a situation where things are getting a little tricky. For this one, I'm going to use my blank pieces of paper. So I want you to find some, because I'm going to conclude this lesson using complex examples. What if polynomials do not have just two? So what I mean by that is two terms, binomial. What if it has more than two? So it can be trinomial, or it can be like four of the terms, or what if it has more than one letter, those kind of situation. So let's give it a shot. What example should I go? Let's say question number 1. Sorry, I'm looking at some of the example. Sadly, most of the example that I put are the one that has just monomial and binomial. Yeah, I may need to make it as an improv style. Then let's just give it a shot. Let's say, and I'm gonna make the monomial a little bit more complex too. What if we have 3x squared, and then inside a polynomial you have 4x squared plus 7x minus 5. First thing first, we cannot use this tile because if you think about it, the exponent or degree is double and double. So how can you make it x to the power of 4 in a diagram? Which is you can't. So we have to rely on our distributive property. And I know it's tedious, but you can still put every single thing. 3x squared times 4x squared plus 3x squared times 7x minus 3x squared times 5. Now, we need to think. 3 and 4. Do the whole number or integer first. That's 12. X to the power of 2, x to the power of 2. If you guys remember about this situation over here, this is one of the reasons why we learn about exponent law first, because if I take these out, then it's a fancy way of saying x to the power of 2 multiplied by x to the power of 2. As you may notice, x and x is my same base, and it's product rule that we're discussing here, which is fancy way of saying we can just add the top exponents, then x to the power of 4 is what we will get, and exponent law can be applied to polynomials too. Just for the heads up. 7 times 3 is 21. X to the power of 2 multiplied by x to the power of 1. That's a fancy way of saying 2 plus 1. Again, same type of rule. X to the power of 3 minus 3x squared. 3 times 5, that's 15. 15x squared. That is one of the examples. My last, what you are going to do if you have multiple different variables inside. What I mean by that is, this type of situation. Negative 4a squared is my monomial, so we are doing exact same type at the first. Negative 4a squared multiplied by 5ab, adding with negative 4a squared multiplied by 6a, subtracting with negative 4a squared multiplied by 7. Something like that. One thing that you need to understand is if you have more than one variable, you gotta pick and choose, because exponent law is only applicable for numbers or variable that share the same base with an exponent. So a to the power of 2 times by a, I can use product rule for that one. So 5 times negative 4 is negative 20. A to the power of 2 multiplied by a is fancy way of saying 2 plus 1. That's a to the power of 3 now. And b, adding with 6 times negative 4, that's negative 24. A to the power of 2 and a, I can use product rule for that one also. So a to the power of 3 minus 7 times negative 4 is negative 28. A to the power of 2 is the only one. That's what I do. And my last step is basically simplification of the sign. Negative 20a cubed b minus 24a cubed plus 28a squared is my final answer. As you may notice, I'm going descending order, so highest to lowest degree. That is today's lesson.